G'day. So I'm going to go over using PlatformIO in this video. I sort of got here because I wanted to upgrade the audio I'm using from a remote ham receiver. I have been having trouble with using Mumble on a Raspberry Pi, so I think this might work better if I just have dedicated streaming audio going from a ESP32 microcontroller. But to do that, I need to sort of change around my whole tool chain. So I'm going to be using PlatformIO to do that. That's going to run on Visual Studio Code. And then I'll be coding in C, C++, and deploying that to the ESP32. So I have a quick look at setting it up, some examples of how to use it, maybe a quick look at how I plan to code for the streaming audio, and then leave the rest for a follow-up video after that.
Here's a quick look at how to get PlatformIO installed. There's some good instructions out on the PlatformIO site. So first you install Visual Studio Code, open the extensions in Visual Studio Code, then you search for PlatformIO IDE, and then you can just click on install and wait. It takes a while to do the first install. So there's good instructions for installing Visual Studio on the Visual Studio page. So here's a quick look at it getting PlatformIO installed. So like I said, once you've got Visual Studio Code installed, then you can go into the extensions, search for PlatformIO, there it is, hit install. This first bit takes about 5 minutes to install everything. Just sit tight, let it go through, wait till it finishes, and do a reload when it tells you at the end. So basically we've got it installed. I'll just show you how to get the first project going as well. The first project will take a long time. Next time you install project using the same framework, it'll go really fast. So go into PlatformIO Home, click on New Project. When you do this, it's going to ask you details about the new project. So give it a name. For my ones, I'm just going to start them off with PIO to identify them as PlatformIO projects. This first one's PIO demo. Then you select the board you're going to use, and you can use Arduinos, Blue Pills, ESP32s, Pi Picos, all sorts of things. So just search for the one you want to use. I'm just going to use kind of a generic ESP32 for this first project. And by selecting this is going to download the board and the libraries it needs for that board. So that's why this first project always takes a long time to get set up first time. So let me select this one here, just the expressive dev module. Select the framework. I'm going to use Arduino. So again, that's going to be part of the libraries that get downloaded. It takes a while. And then the thing I do differently from kind of the default is I put all my projects in a C projects directory, so I'm going to continue to do that. So I'm going to set that as the initial directory for this project I'm making as well, and let it go. So let this run. Like I said, the first time you do this, it can take a while to load all the libraries, especially if you don't have Arduino loaded. So this one took me about 12 minutes. After that, it's a lot faster. Then when it's finished, you just say you trust that folder if you haven't set it before, and there we see the new project. So let's have a look at what PlatformIO gives you as the basic project structure when you start a new project. So it has an include folder, and the nice thing is they have README files about what each of these folders are used for. So it includes to add your own location for your own custom headers, lib files for where you've created files or libraries just for your project, and they give you the suggested structure for the use of those folders as well. And the README source is where your C++ source is, and because I selected Arduino as my framework, it set me up with these two routines, which are the common Arduino ones, in my main CPP folder. So I put what I want to happen initially at first inside the setup function here, and then anything that I want to happen repeatedly afterwards in the loop function. So that's just like Arduino IDE. The only thing they do include is the Arduino header. You won't see that in the Arduino IDE, but it's included in here. There's a folder for any unit tests you put together. The git ignore is there for basic things that you want to ignore for Git. And this PlatformIO is something that you'll probably use a lot. So when you do select the board and the framework, that's put into an environment setting in the PlatformIO, and the PlatformIO is used to configure anything specific about your project for a particular platform. And see, because I selected a fairly generic ESP32 board, select the platform has just been Expressive32, boards ESP32 dev, and framework is Arduino because I selected Arduino framework. What you do find is if you want to add to this additional boards to this project, you can go in and add those in, and there'll be another environment in here. So this can actually compile for multiple environments from the same set of source. So you could have the same program being, say, used on ESP32, on a Pico, PyPico, Arduino, STM32 Blue Pill. As long as the code's compatible, then by targeting the different platforms, it'll bring the specific libraries and things in for that board. And you can compile either for all those at once. So if you're trying to build for a lot of boards at the same time, you can do that. Or if you just want to be able to swap between the different environments or different boards, you can just select compile and builds for those specific boards when you do it. So let's have a look at adding a blinking LED program for my ESP32, and this is kind of the hello world of the embedded controller world. So best way I found of getting started on this is go to Docs, go into Frameworks. I'm using Arduino framework. Run down, see there's examples there, and I'm going to choose this set of examples, Arduino for Expressive32. See, that's what I'm working with. And here, the nice thing is it gives you a whole bunch of example code that's out in GitHub for you to use. And I'm going to try this one here, Arduino Blink. And there's quite a lot of examples out there. So if I go into Source, Blink CPP, so this shows me what I should be putting, in my case, into the main folder. So let me just let's get a copy of that. I'll bring up my project, and I'm just going to replace all this code with what I just copied. And this should all work. The only thing to look out for is the built-in LED may not have the correct I/O for my particular board, but we'll try it out. If not, then we'll dig into why it's not. Some of the nice things about using PlatformIO with Visual Studios is you can do things like, let me show an example here. So I want to set up the serial port. So it'll code complete for me, and let me set it to 9600 board. It'll show me errors where I'm, in this case, missing something like a semicolon. And also down here, just in this loop, I'll again use serial, use code complete. So when I enter a full stop, it asks me what I want to do. So I want to do a print line and just put a comment here. blink ... that'll work. Again, got an error until I put the semicolon in there. So it's nice code completion, automatic visual error detections, all good. So let me save that code, and I have an ESP32 plugged in at the moment to my computer. So one of the nice things it does is it automatically detects if you have the board attached and knows that's your target. So let's do a compile first. Hopefully this goes through without errors. The first compile, usually on a new build, can take a while it brings in libraries and things. This one didn't take too long. A lot of the libraries are already compiled. I've done this a few times. So 6 seconds. And looks like I don't have any errors there. So I'm going to use this to upload it to the board. So hopefully this will go out to the ESP32 and start it blinking. So it's automatically connecting, uploading. And we see it blinking, which is good. Now let's see if my serial statements work as well. So it should be printing out this blink word every time it goes through a blink cycle. The way you start up the serial monitor is this icon here. And there we see it's calling out blink. So that's connecting to the serial port at 9600 board at the moment. You can increase that to a higher rate. But if you do, you need to change the PlatformIO any file to set the serial monitor to the new rate, because by default it's in 9600 as well. So that's another use for the PlatformIO any file, is to set up things like that. Another nice integration that is useful for me is the source control. So if I go to source control, at the moment I haven't got Git set up for this. So I can either just initialize the repository, which will make the local Git repository, or I can set that up and publish to my GitHub repository at the same time. So let's call this POI demo 1. So it already knows about my GitHub repository because I'm signed in. I'll just do this as a private repository just to demonstrate. Looks good. Hit that. And that should be it. So let me bring up my browser, and you see how out in GitHub now, PlatformIO and that whole project is now up as a GitHub repository, and now I can make sure I've got source control working on anything I'm doing in this project. So let's have a look at another way of using the examples. So I'm going to go to the PlatformIO home. I clicked on the home icon, and in this case I'm going to use the project examples instead. So I'm going to select an example. I'm going to use express if example. In this case I'm going to do a Wi-Fi scan, and I can do an import, which will bring that whole project in. I trust the author, and we should be ready to go. So the difference with this project you see here is the platform ini has actually been set up to support multiple boards, and I can do a compile and it'll actually compile for all these different boards. But if I just want to focus on one board, the one I've got connected at the moment, I'm going to go with this one here, which is kind of the generic version. Should be ready to go. So let's do a build. Okay, I'll show you one more thing in the platform ini here. You'll see there's another use for the platform ini is to set the monitor speed. So you remember in the last example is 9600 board. Now I've put it up to a higher speed, and that's because in the source it's using the higher speed for the serial interface. So what this should do is fire up and then scan for Wi-Fi connections that are nearby. So let's do the deploy this time. Connecting to my device that's on COM6, which it automatically recognized it was there. So it should be deployed. Let me bring up the terminal and we'll see if it's working. So it's starting the scan and found all these Wi-Fi networks which are around my house here. Just to note, because it's an ESP32, it's only finding the 2.4 gig Wi-Fi networks, so it's a much shorter list than probably really is here. But it looks like that's working successfully, so that's another way of using the examples. Okay, just wanted to go over why I'm using C++ instead of, normally I'm using Micropython on microcontrollers. And it's mainly because I'm doing a sound application and I really need the precise timing that C++ gives you. Micropython can have things happening in the background that you're not expecting, like garbage collections. Also, because it's a higher level language, it's usually calling functions to do a lot of what it does, so it's not so close to the metal. So you're never quite sure, what the timing for those functions are. So that's why I swapped over to C++ for this particular application, where I want to start streaming audio from my ham radio. So I'm going to start with my Blink application here and just show you how I can cut it down and get some square waves out of the ESP32. So first I'm going to clear out some of the stuff I don't need. So instead of using the LED as the output, I'm going to define sound as pin 13. I'm not going to use serial, but going to initialize the pin 13 for output. Don't need this serial out there. And same thing, I'm going to quickly flip from low to high to get the square wave, but to do that at increased speed I'm going to use delay microseconds. Let's do about 5. See how that goes. Same here on the other side. Looks good. Okay, no errors. Let's compile that first. And let's deploy it. And for this particular ESP32, I need to hit the boot button. There it goes. It's downloading the program. And we can see on the oscilloscope here that we're getting a square wave output. Let me see if I can change the time base for that. So that's a better view of the square wave coming out. And you see it's actually running at 84 kilohertz, so that's pretty fast. And it's probably a bit faster than this little oscilloscope can keep track of, but you can see how we can manage sound with C++ pretty well. So that's about it for this video. So I've got PlatformIO going, so I've really got my C++ tool chain to an ESP32 all set up. Next video, that's where I'm going to really get into some of the C++ coding for doing audio. Basically, I want to do like a wireless microphone type thing. There's some good examples out there. I've put a link to one good YouTube video about putting an ESP32 walkie-talkie together, which will be part of the basis for this. There's also some ESP32 sound libraries that are probably going to be useful as well. So I'm going to dig into that for a while, learn a bit more C++ coding, and then next video I should be able to wrap up and get some audio streaming going to and from my ESP32.